In this class, inshallah, we are going to continue the classes on Bernoulli's equation. Bernoulli's equation. So see here, next question I wrote on the board. Before going to the question, we must by heart this formula. Integration of log x is x into log x minus 1. Integration of log x is x into log x minus 1. So let me start the question. X dy by dx plus y equals to x square log x. How to start? Whatever we are having y here, we have to divide each term by this y square. The first step is whatever we are having y square here, we have to divide. And secondly, in the equation, we should not have x here. Bernoulli's equation, we do not have x here. So we have to remove this also. Therefore, divide by x y square. To remove x, we are taking x, and the method is y square on both sides. So let me divide each term. X divided by xy square dy by dx plus y divided by y square equal xy square equals to x square y square by xy square log x. So what is left here? If we cancel this one, it is left with 1 by y square dy by dx plus, if you cancel it, you will left with 1y here, 1 by xy equals to x square y square cancel. We left with x log x. So what is the next step? The next step is whatever we are having y here, we have to suppose some else. Suppose t. We must suppose this one as t. Put 1 by y equals to t. Put 1 by y equals to t. So let me differentiate this one. What is the formula of d by dx of 1 by x? D by dx of 1 by x is minus 1 by x square. D by dx of 1 by x is minus 1 by x square. Therefore, d by dx of 1 by y will be minus 1 by y square. Let me differentiate with respect to x. So write dy by dx equals to t is dt by dx. Bring this minus here. Therefore, we get 1 by y square dy by dx equals to minus dt by dx. Now the question will change us now. See here. Let me change this question. 1 by y square dy by dx is minus dt by dx. 1 by y square dy by dx is minus dt by dx plus, now 1 by y we wrote t, 1 by y we wrote t, so this will become t by x. 1 by y is t, so this will become t by x equals to x log x. Now this Bernoulli's equation, now let it take out minus from here. To take out minus from here, multiply with minus each term, multiply with minus each term. So multiply by minus, so this will become plus dt by dx. This will become minus dt t by x equals to minus x log x. Now this becomes the linear differential equation. So we do this procedure using the method of linear differential equation. Let me compare with linear equation. Dy by dx plus py equals to q. This is the linear differential equation. So in place of y we are having t. In place of p, compare what will be this, minus 1 by x. P equals to minus 1 by x. P equals to minus 1 by x. And q equals to minus x log x. Now we are having two steps. First we have to find integral factor. Its formula is e to the power of integration p dx. E to the power of integration p is minus 1 by x dx. E to the power of minus integration of 1 by x is log x. Now watch carefully. E and log will get cancelled, but first we have to take out minus from here. After that we can cancel it. Minus means we take minus 1. So bring this minus 1 in the power of x. This is a formula, m log x equals to log x power m. This m will go here. So in the same way, let me do this one, equals to e to the power of log x power minus 1. So e log will get cancelled. We left with x power minus 1. X power minus 1 will be 1 by x. So we got integral factor. Now the second step is solution. Solution is y into integral factor equals to integration of q into integral factor dx. But we must write in place of y t, because here we are having t. So in place of y you write t into integral factor. We got 1 by x equals to integration of q. Integration of q, we are having q as minus x log x into integral factor. Integral factor is 1 by x dx. So one step, two steps are left. Now you cancel this x and 1 by x and replace t with the initial value. In the initial we kept, here you see the value of t is 1 by y. So let me substitute the value of t is 1 by y into 1 by x equals to minus integration of log x dx. Now this will be 1 by xy, 1 by xy minus integration of log x. We have seen that earlier. This formula is x into log x minus 1 plus c. So this is the answer for this question. Now see the next question. Before going in these questions, I already explained in detail in the last part about the Bernoulli's equation. So if anyone has not seen that part, I request first to observe that all the formulas in the next previous part. Okay. Now see here, till now we have done questions based on dy by dx plus py equals to q into y power n. Sometimes the question will be reversed like this, dx by dy. In place of dy by dx, we'll have dx by dy plus py, we will have px equals to q into y power n. Here it will be x power n. So here the method will become divide each term by x power n. So let me do one question like this. You do one thing, you multiply this with xy into 1 and this, and bring this here. You see here like this, xy into 1 will be xy plus x into x square, and x into x y into y square y cube equals to xy into 1 xy, x into x square, x into y square I cube. Bring this on the other side, it will become dx by dy. Dx by dy. Now you do one thing, you bring this xy here, we can write like this, dx by dy minus xy equals to x square y cube. Now let me do like this method, dx by dy, dx by dy, dx by dy, and here we will see that this is x. No, now we have to divide these terms, we have to divide these terms with x square like this, x square. So divide both sides by x square, divide both sides by x square. So this will become 1 by x square dx by dy minus xy by x square equals to x square y cube by x square. Now x square will get cancelled, this will get cancelled. What is left here? 1 by x square dx by dy minus y by x equals to y cube. Now from here, what is the procedure? We have to suppose this as t. Put minus 1 by x equals to t. Put minus 1 by x equals to t implies. Now let me differentiate both sides with respect to y, because we are having here dx by dy, we are having dx by dy. So we have to differentiate this both with respect to y. Now minus d by dx of 1 by x is minus 1 by x square with respect to y, so write dx by dy. D by dt of t will be 1, but we are differentiating with respect to y, therefore it will become dt by dy. dt by dy. Minus of minus will become plus. So it will be 1 by x squared dx by dy equals to dt by dy. Now the question will change us now. See here, let me change the question from here. 1 by x squared dx by dt. This will become dt by dy. dt by dy. 1 by x squared dx by dy will become dt by dy. Minus 1 by x we have taken t. So it will become plus t into y. Minus 1 by x. Minus 1 by x is t. So t into y equals to y cube. T into y equals to y cube. Now let me compare with the general equation. The linear equation of this type, dx by dy plus dx by dy plus px equals to q. Now watch carefully. In place of x we have t. In place of x we have t. In place of x we have t. That means p value is y. P equals to y. Q equals to y cube. In place of t we have x. That means x is t. Therefore p is y and q is y cube. Now let me first use the formula integral factor equals to e to the power of integration p dy. We are changing everything. In place of x we are writing y. In place of x we are writing y. In place of y must write x according to the previous method. Now see here, equals to e to the power of integration p. The value of p is y dy. Now integration of x is x square by 2. Integration of x is x square by 2. In the same way, integration of y will be y square by 2. So we'll get integral factor equals to e to the power of y square by 2. Now the second step is solution is, its formula is not x into integral factor, sorry, y into. Its formula is x into integral factor equals to integration of q into integral factor, not dx but dy. Now in place of x, you see here we are having t. In place of x we are having t, so I write t here, t into integral factor. The integral factor we got e to the power of y square by 2. T into integral factor equals to integration of q. In place of q we are having y cube into integral factor. Integral factor is e to the power of y square by 2 dy. Once more, you see here, t into integral factor equals to integration of q into integral factor dy. Now you substitute the value of t. In the previous we have taken t is minus 1 by x. Minus 1 by x. So in place of t, we write minus 1 by x into e to the power of y square by 2 equals to integration of, now watch carefully, y cube we can write y square into y. Y cube, let me write y square into y e to the power of y square by 2 dy. Now there is a method here. We have to solve this integration using, let me do one thing. Okay, let me change once more. Now we have to solve this using substitution method. How is the method? Let me do one thing. Put this value as something else. Y square by 2 equals to u, suppose. Now differentiate this. Y square will be 2y. 2y by 2. Differentiation y is dy equals to differentiation of u is du. So 2 will get cancelled. So y dy we can keep du. Y dy we can keep du. In place of y square you bring 2 here. In place of y square we can write 2u. Now change here. See here. This you write as it is, minus e to the power of y square by 2 by x equals to integration of, see here, y square. Y square is 2u. Write 2u, 2 outside, u here. Now y dy. Y dy is du. Y dy is du. Now what is left here? We left with e to the power of y square by 2 is u. Now see here, this is of the form integration by parts. Integration by parts. So for this we have to use formula integration of f of x into g of x dx. Its formula is f of x integration of g of x dx minus whole integration d by dx of f of x integration of g of x dx whole dx. Already previous class also we used this formula. So let me change this into the formula. You write this as it is minus e to the power of y square by 2 by x 2 into, no, this is the formula in f of x. F of x is u into integration of g of x. Integration of e power x is e power x, so this will be e power u minus whole integration d by dx of f of x. D by du of u will be 1, like d by dx of x is 1, therefore d by dx of u is also 1 into integration of e power u. Integration of e power u will in e power u du. On the last method, last step, again d by dx of e power u will be e power u. Let we take common e power u from this, so plus c, right? E to the power of minus e to the power of y square by 2. Let me bring 2 here, x here, so it will be 2x. If I bring here x, 2x, otherwise you keep here itself 2 into, you take common e power u, is left with u minus 1, okay, plus. Now lastly change the value of u we have taken here y square by 2. So in place of u we take y square by 2. It will become minus e to the power of minus y square by 2, sorry, y square by 2 by x equals to 2 into e per u. U is y square by 2 into u is y square by 2 minus 1 plus. Now the last step, let you do one thing. If you take LCM here, 2 ones are 2, and this 2 will, and this 2 will get cancelled. So the answer will be minus e to the power of y square by 2 by x equals to, let me take common LCM 2, 2 will get cancelled, e to the power of y square by 2 into y square minus 2 plus c. So this is the answer. We can write answers in many ways. I'm ending here. Okay, we can show the answer in different ways. Now to save the time, the next question I wrote on the board, I will just explain in short, because if we do lengthier, the video will become very lengthy. So let me go in short in this question. Before going to the next question, actually we want to know how to find sine inverse x. In the previous classes, in the 12th class, we learned that to find sine inverse x, we have to write sine inverse x into 1. We must suppose the sine inverse x as f and 1 as g, and we will do this, solve this by integration by parts, this formula. Integration of f of x into g of x is f of x integration of g of x dx minus whole integration d by dx of f of x integration of g of x dx. So this is f, this is g. Let's use the formula f of x integration of g of x minus whole integration d by dx of f of x integration of g of x dx whole dx. Now integration of 1 is x. Integration of 1 is x. D by dx of sine inverse x is 1 by under root of 1 minus x square. D by dx of sine inverse x is 1 by under root of 1 minus x square. Integration of 1 is x. Integration of 1 is x. Now you write this x here, x sine inverse x minus x by under root of 1 minus x square. You see here how to solve this one. If we have minus 2 in the numerator, it will be the differentiation of 1 minus x square. Differentiation of 1 is 0, and minus x square is minus 2x minus 2x. So if we have minus 2 here, it will become f dash x by root of f of x. This is the formula for 2 root f of x. F dash x by root of f of x is 2 root f of x. We already have x here. If we have minus 2 here, it will become the formula of this. So to get minus 2 here, multiply and divide by minus 2. Dividing by minus 2, multiplying by minus 2, dividing by minus 2, multiplying by minus 2, because now this becomes the formula f dash x divided by under root of f of x. This is the basics of 12th class, intermediate second year. F dash x by root of f of x. So this will become 2 root f of x. 2 root f of x. So x sine inverse x minus into s plus 1 by 2. 2 root f of x. 2 will get cancelled. So we just want to know what is the integration of sine inverse x. So we got the integration of sine inverse x as x into under root of 1 minus x square plus under root of 1 minus 1. Why we have done this means, in this, actually this question, at last we have to find integration of sine inverse x. So we find like this. Okay, now in this question I will substitute directly the integration of sine inverse x is x into sine inverse x plus under root of 1 minus x square. Now let me go into the Bernoulli's method. No, the method is 1 minus x square. See here, what is the concept? We have to divide by y cube, and we must not have here 1 minus x square. So divide by 1 minus x square into y cube each term. Dividing by 1 minus x square into y cube all the terms. Now you get cancelled with this one. What is left here? 1 by y cube. Now here you see y and y cube will get cancelled. You will left with y square. Here y cube will get cancelled. You left with sine inverse x by 1 minus x squared. Now compare this. Okay, what is the method here? Whatever we are having y here, we have to suppose t. So what is here? We are having 1 by y squared. So in the Bernoulli's method, we suppose this value as t. We suppose this value as t. Now bring this 2 here, y square upwards, it will be in the numerator y power minus 2. Now d by dx of x power n is n into x power n minus 1. Because we did y differentiate, therefore dy by dx. Here we have t, dt by dx. Now bring this will be minus 2 y power minus 3. Y power minus 3, if you bring in the denominator, it will be y power 3. Now bring this 2 here, it will be minus 1 by 2. Bring this minus 2 here, it will be minus 1 by 2. Now we got 1 by y cube dy by dx equals to minus 1 by 2 dt by dx. Now let me change this one. 1 by y cube dy by dx. We got minus 1 by 2 dt by dx. Plus 1 by y square, we suppose at t. Then what is left? X by 1 minus x square. Now see here, to bring this into the linear form, we have to take out this minus 1 by 2. So multiply by minus 2. So minus minus will get cancelled, 2 2 will get cancelled. If you multiply with minus 2, it will be minus 2 tx. If you multiply with minus 2, this will be minus. Now it is in the form of linear differential equation. Now compare this with dy by dx plus py equals to q. So in place of y, we are having t. In place of p, we are having minus 2x by 1 minus x square. In place of q, you are having minus 2 sine inverse x by 1 minus x square. So the integral factor is e to the power of integration p dx. P dx. There is a formula you see here, f dash x by f of x. F dash x by f of x is log of f of x. So e log will get cancelled. The integral factor is 1 minus x squared. Now the solution is y into integral factor equals to integration of q into integral factor dx. In place of y, we are having t into integral factor equals to integration of q into integral factor dx. 1 minus x square, 1 minus x square will get cancelled. You take out 2 outside, and the next thing is you keep in place of t the value of t. The value of t is what we suppose. The value of t is 1 by y square. So in place of t, 1 by y square means it will be in the denominator, minus 2 sine inverse x. In the previous, just now, we did integration of sine inverse x. Now last step, you substitute the value of integration of sine inverse x as x into sine inverse x plus under root of 1. In exam, if you got here, you suppose this as equation 1. You solve this integration of sine inverse x separately, and then you put into the answer. You will get this answer. So because this question is very big, so I explained in short for you. You practice it. Let me do last question, one more question on this. See the next question. X cube secant square y dy by dx plus 3x square tan y equals to cos x. It is similar of Bernoulli's equation, but little different. You see here, if we put tan y equals to t, we get differentiation secant square y. This again changes to linear differential equation. So we have to start like this. Put tan y equals to t. Why? If you differentiate both sides with respect to x, d by dx of tan will be secant square y. Differentiation with respect to x, dy by dx equals to dt by dx. Watch here. Now secant square y dy by dx, we can put dt by dx. So what is left here? X cube secant square y dy by dx is dt by dx, dt by dx plus 3x square. Now tan y is t equals to cos x. Now to bring in the form of linear, we have to divide by x cube. Divide by x cube. So if we divide by x cube, what is left here? Dt by dx plus, if we divide by x cube, x square, x will get cancelled. We left with 3t by x equals to cos x by x cube. Now compare with the general equation, linear equation. We have dy by dx plus py equals to q. So the value of p is 3 by p equals to 3 by x and q equals to cos x by x cube. So first step is we have to find integral factor e to the power of integration p dx. E to the power of integration p is, take out this 3 outside, 1 by x dx 3. Integration of 1 by x is log x, so this will be log of x mod x. E log will get cancelled, but you have to take out 3 from here. If you take out 3, it will become x cube. E to the power of log x cube. Now e log will get cancelled. We left with integral factor x cube. So we got integral factor. Now the solution is y into integral factor equals to integration of q into integral factor dx. Now we don't have y here. In place of y, we are having t here. So t into integral factor. We got integral factor as x cube equals to integration of q. We are having q as cos x by x cube into integral factor. Integral factor, we are having x cube dx. So x cube will get cancelled. Now what is the value of t? Initially we suppose t as tan y. So this will be x cube into tan y. Integration of cos is sine. So sine x plus. So this is short question. So inshallah we will continue this. Inshallah in the next class we have done few questions on Bernoulli's equation. So I request to do some more practice from the textbooks. In the next chapter, inshallah, next part, we will continue with exact differential equations, methods of exact differential equations, inshallah, in the next class.